So, you've done all the hard work. You've run the survey, you've collected the test scores, you've gathered all the information. And now you're just staring at this spreadsheet packed with numbers and words. The big question is, now what? How do you actually turn all this raw data into something that makes sense? Well, that's exactly where descriptive analysis comes into play. It is the absolute first and honestly the most crucial step in making sense of everything you've collected. Today, we're going to break down the core ideas you need to know to summarize, visualize, and really understand the story your data is trying to tell you. So let's jump right in. Okay, before we calculate a single average or draw a single chart, we have to know what kind of data we're even dealing with. Now, I know this might sound a little bit like theory, but trust me, getting this wrong can lead you to some completely wacky and meaningless results. So let's start with the absolute foundation. First up, we've got nominal data, or định danh. The easiest way to think about this is they're just labels, they're categories. You can count them for sure, but you can't logically put them in any kind of order or do math with them. Like, you can count how many public and private schools you have, but it makes zero sense to say public is somehow greater than private, right? They're just distinct groups. Next, we move on to ordinal data, or throughbuk. Now, this is where we add a really important new piece, order. The data here has a meaningful rank. We all know that agree is more positive than neutral, or that a good ranking is better than fair. But, and this is the key thing to remember, we don't actually know if the gap between good and fair is the same as the gap between, say, excellent and good. The steps on the ladder aren't all the same size. Let's level up again to interval data, or huang. Now, with interval data, those steps on the ladder are evenly spaced. The difference between an IELTS score of 6.0 and 7.0 is the exact same as the difference between 7.0 and 8.0. But here's the catch. There's no true zero. Think about it. A temperature of 0 degrees Celsius doesn't mean there's a complete absence of heat. In the same way, getting a 0 on a test doesn't mean you have zero knowledge of the subject. It just means that was the lowest possible score on that particular test. And that brings us to the top tier, ratio data, or dile. This is the whole shebang. It's got everything the others have, order, equal intervals, plus that all-important true zero. Here, zero actually means none. When we say a student spends 0 minutes on a task, it means they literally spent no time at all. 0 words learned means exactly that. And because of this true zero, we can make really meaningful comparisons, like saying student A spent twice as much time as student B. So let's just quickly recap. Nominal is just names. Ordinal adds order to those names. Interval makes the space between the order equal. And finally, ratio gives us a true 0 point. Seriously, understanding this is the key that unlocks all the right tools for your analysis later on. Okay, so once you know what type of data you have, descriptive analysis really boils down to answering 2 fundamental questions. First, where's the center of my data? What's a typical representative value? And the second question is, how spread out is my data? This is all about understanding how consistent or inconsistent your data set really is. So let's tackle that first question. How do we find that typical value? That one single number that can do the best job of summarizing the entire group. Well, we have 3 main tools in our toolbox for this job, and each one tells a slightly different part of the story. We're talking about the mean, the median, and the mode. The mean, or 중간점, is what pretty much everyone thinks of when they hear the word average. You just add everything up and divide by how many you have. It works great when your data is nice and symmetrically distributed, but it has one huge weakness. It's super sensitive to outliers. Just one really high or really low score can drag the whole average up or down and give you a pretty misleading picture of what's typical. Now, to fight back against those outliers, we have the median, or 中vị. The median is super simple. It's just the middle number once you've lined all your data up in order. And because it's all about position, not value, it pretty much just ignores those extreme outliers. So if you're dealing with messy, real-world data, think income levels or house prices, the median is often going to give you a much more realistic idea of the center. And last but not least, we have the mode, or 요위. This one's the simplest of them all. It's just the value that shows up most often. Now, while you can use it with numbers, its real superpower is that it's the only measure of center you can use for that nominal categorical data we talked about earlier. You can't find the average of male and female, but you can absolutely find which one is the mode. Okay, so we've found the center, but that's really only half the story. Now we've got to answer that second big question. Are all the data points clustered tightly around that center, or are they kind of spread out all over the place? This is what we call measuring dispersion. And the most powerful tool for this is the standard deviation, or dollichan. The best way to think about it is as the typical distance that any single data point is from the average. It boils down the entire spread of your data into one single powerful number. Imagine this. You have two classes, and they both get the exact same average score on a test. But the class with a low standard deviation is homogeneous. Pretty much everyone scored very close to that average. It's a very consistent group. Now, the class with a high standard deviation is heterogeneous. The scores are all over the map. You've got some high flyers and some who really struggled. The average score is the same, but the reality in each classroom is completely different. That's what standard deviation tells you.
Another fantastic measure of spread is the interquartile range, or IQR. Just like the median, the IQR is tough and doesn't get pushed around by outliers. It basically just looks at the range of the middle 50% of your data and completely ignores the super high top 25% and the super low bottom 25%. It's a really stable way to see how spread out the core of your data is.
Now for the really cool part. When we take our measure of the center and combine it with our measure of the spread, something really powerful happens. We start to see the overall shape of our data's distribution. And that shape, well, it can tell you a whole lot. So the shape everyone hopes for is the normal distribution. You know, the classic bell curve. It's perfectly symmetrical, most of the values are clustered right in the middle, and it tapers off evenly on both sides. In this perfect little world, your mean, your median, and your mode are all sitting right on top of each other. In education, seeing this often means you got a well-designed test that wasn't too easy or too hard.
But let's be real, real-world data is almost never perfect. It's usually skewed one way or the other. Now, a distribution is always skewed in the direction of its long tail, so a left-skewed or negative distribution has that long tail stretching out to the left. A right-skewed or positive one has its long tail on the right. Understanding this is so important because it has major practical implications.
Check this out. If a test was too easy, what happens? Most of the scores bunch up at the high end, right? This creates a negative or left skew. Those few low scores act like an anchor, dragging the mean down below the median, which is the true center. This isn't just some abstract shape. It's a huge red flag telling you your test might have been too simple. And the exact opposite happens with a really hard test. It creates a positive skew where few star students pull the mean up, making the whole group look better than they actually perform. All right, the last step in all of this is actually showing people what you found. A good chart can tell your story way better than a table full of numbers ever could. But you have to choose the right chart for the job. Here's a quick cheat sheet that ties it all together. For that nominal data we started with, like comparing public versus private schools, a bar chart is your best friend. The bars are separate because the categories are separate. Now, to see the shape and distribution of continuous data, like test scores, you need a histogram. Notice how the bars touch? That's to show the data is continuous. A pie chart? Super simple. Use it when you want to show parts of a whole, like the percentage of students in different majors. And finally, a box plot is an amazing tool for comparing the spread, that standard deviation and IQR we talked about, across several different groups all at once. So here's the bottom line. Every single one of these descriptive statistics, the mean, the median, the mode, the standard deviation, the shape of the curve, each one tells a unique part of your data story. They are not just numbers you report in a table. They are clues. So the real question is, are you using the right tools to actually listen to what your data is trying to tell you?